Hi, good afternoon. I hope you're doing well. This is Kumar, and my student ID is 101236674. I'm teaming up with Saloni Jagdishbhai Prajapati, and this is the submission for final project. We chose the alternative one, which is the crime rate in the city. So first of all, in the project, we'll import the crime CSV file, which is provided to us in the project. And after that, we'll import the required libraries, pandas for extracting the data frame from the CSV file, the linear model, because we need the linear regression, the model selection, which will split our data into training and testing data. And from sklearn.metrics, we are getting the mean squared error, which we have to find to check out how accurate are our predictions from the machine. So let's import it. Okay, the libraries are imported. So these are the values in the data frame. So X1 stands for overall reported crime rate per 1 million. X2 stands for reported violent crime rate per 100,000 people. X3 is the annual police funding in dollars per resident in that area. X4 is the percentage of people who are of age more than 25 with 4 years of high school. X5 is the percentage of people 16 to 19-year-olds which are not in high school and not graduates. X6 will be percentage of people 18 to 24-year-old in college, and X7 will be the percentage of people 25 years, more than 25 years with at least 4 years of college. Right. So let's import the data frame from the CSV file, and these are the first few values. Now we were asked about the shape of the data frame. So we have 50 rows and 7 columns. Now let's go and find out the summary of the data. And here it is. For all the columns, we have the count, mean, standard deviation, minimum, maximum value, and the percentiles. So let's check if the data has any nan values. Nan stands for not a number, and as we can see, there are 0 nan values in the data frame. Now we're using the inline matplotlib to plot a histogram first and then a bar graph, because we had to display the data in 2 different forms. Let's go. So this is the histogram for the data given for x1, x2, x3, x4, x5, x7, and then here's the bar graph for the data. So yeah, it's divided into bars, and this one is a histogram frequency. So these are the parameters again, just for reference from the bar graph and histogram. So now what we will do is we'll define the data and the target here, or I think we can call it label 2. The target here shows like what are the values. It's our solution, and data is more like its input in the system so that it could get an output. We could get an output, and we'll compare that to our target. So let's go. We have done that. Now we'll split the data into training and testing data sets. So we'll need to train our linear regression model. So the data train and target train will input the data in the machine, and then we will be telling the machine what are we looking for, what are the answers, and data test and target test will be when we are looking at the predictions. So let's split the data. Now we'll need the linear regression model because we have to find the predictions using that specific model. Now let's input the training data and training target into the linear regression model. You can see it's right here. Now we'll predict what will be the solution from the test data into the. Okay, so these are the values. We are using the last 4 columns. which are x4, x5, x6, and x7. And let's see how close it is to our test target. And as we can see, it is pretty close. We can get a summary of all that from getting the mean squared error, and here it is. It's 89.185 something. So yeah, this is our submission for the assignment, the final project. Thank you.